Do you want to multiply two binary numbers together? In this episode of the House of Hacks, we're going to look at how easy this operation really is. Hi makers, builders, and do-it-yourselfers, Harley here. The playlist up here contains previous episodes where we looked at what binary numbers are, how to count in binary, how to convert between the more familiar decimal base 10 numbers and binary, and how to do addition and subtraction on binary numbers. In this episode, we'll look at multiplying binary numbers together. Back when we learned how to multiply decimal numbers in school, we had to memorize a table that looks something like this. If you know this table, you already know everything there is to know about multiplying binary numbers. The cool thing is, multiplication in binary is exactly the same as decimal, except you only use these two rows and columns from the table you've already learned. And the process is exactly the same too. Let's take a look at a couple examples and then a couple shortcuts. Let's take 7 times 3. Just like in decimal, we first multiply the units, and we write that down under the equal bar. Since we're multiplying by 1, we just write down the first number. Then we add a 0 placeholder and multiply by the next column. Since we're again multiplying by 1, we write down the first number again. And finally we add the two numbers together to get the total. 1 and 0 is 1. 1 and 1 is 2, which in binary is 1, 0. So we write the 0 and carry the 1. 1 plus 1 plus 1 is 3, represented in binary as 1, 1, so write the 1 and carry the 1. Again, 1 plus 1 is 1, 0, so write the 0 and carry the 1. 1 and 0 is again 1, so write the 1 and we're done. Let's double check this by converting the result to decimal. Remember, each column is a power of 2, and we add the column values that contain a 1. Looking at the values of the columns, we have 16 plus 4 plus 1, which is 21. Let's do another one, 5 times 5. Starting with the units, we multiply by the first number times 1 and write that down. We put down a 0 placeholder for the next column, but notice we're now multiplying by 0. So we ignore that column since 0 times anything is 0 and add another placeholder and move to the next column. We're again multiplying the first number times 1 and we write that down. And now we're ready to add. 1 and 0 is 1, 0 and 0 is 0, 1 and 1 is 2, so write down the 0 and carry the 1, 1 and 0 is 1, and finally 0 and 1 is 1, giving us the result 11001. Again, we can verify this by converting to decimal. So we have 16 plus 8 plus 1, giving us 25. There are two shortcuts we can observe. First, since we're always multiplying by either 0 or 1, the numbers we're adding together are always nothing for 0 or the first number shifted by the column that contains a 1 in the second number. So this is a really mechanical process of just writing down the first number multiple times, shift it as needed, and then adding the numbers together. As an example, we'll take this random number and multiply it by this random number. We write down the first number with the units under the second number where the columns contain 1s. We can add placeholder zeros if it makes it easier to keep track of the columns. And then we just add. The second shortcut is related to multiplying by powers of 2. Let's go back to decimal for a minute. You probably know the shortcut for multiplying by a power of 10. For 10, 100, 1000, and so forth, all we have to do is add the appropriate number of zeros to the number we're multiplying. 3 times 10 is 30, 3 times 100 is 300, and so forth. Binary has a similar concept, except it's related to powers of 2. 2, 4, 8, 16, and so forth. Every time a 0 is added to the end of a number, it's the same thing as multiplying by 2. So if we are multiplying by 2, we add 1 0. If we're multiplying by 4, we add 2 zeros, and so forth. And since powers of 2 in binary look just like powers of 10 in decimal, we really don't have to think about it. All we have to do is add zeros and we're done. In this episode, we looked at how binary multiplication is using all the same ideas as decimal multiplication we're already familiar with. We also looked at two easy shortcuts to mechanically handle the multiplication and multiplying by powers of 2. Binary is a common non-decimal numeric base, but really any number can be used as a base for a number system. Leave a comment below if you've worked with number bases besides decimal and for what purposes. If this is your first time here at House of Hacks, welcome, I'm glad you're here, and I'd love to have you subscribe. Through these videos, I hope to inspire, educate, and encourage makers in their creative endeavors. In spite of this series, usually this involves various physical media like wood, metal, electronics, photographs, and other similar materials. So subscribe and I'll see you again in the next video. Thanks for joining me on our creative journey. Now go make something. Perfection's not required, fun is.